What do you mean? They're still going to learn. All right, let's do this one. A plus b to the 5th power. So, I think you guys have the 5th row in your notes of Pascal's triangle, right? It's 1, 5, 10, 10, 5, 1. So those are the numbers that go in front of each term. So let's see. It's going to be 1 times a. What power?
5.
5th power. Yep. Plus. Now, how do we know it's going to be a 5? The triangle. You got to look at the 5th row. The second number in is a 5. So it's 5 times a. Come on, a to the 4th. B to the 1st power. Now, I think I pointed this out to you last time, but I want to make you aware again. If you look at any particular term and add the exponents, 4 plus 1 is 5. Or here we have just a 5. If you add any of the exponents in any term, it has to equal the original exponent. Okay. Because if you're raising it to the 5th power, you have to look at the 5th row of Pascal's triangle. 1, 5, 10, 10, 5, 1. So, what's the next term? 10. A to the 3rd. B squared. And again, if you look at the exponents, 3 plus 2 equals 5. Next term. 10. A squared. B to the 3rd. Now, before we go any further, I want you guys to just consider one thing. This may not be a short process. I understand that. But think about the alternative. If we're not going to do it this way, the alternative is to write a plus b 5 times, like this, and multiply it all together. Does that sound like a good idea to anybody?
Yeah.
That would take forever. That would take forever. So, as bad as you think this method is, it would be a lot worse without it. Next term. 5. A to the 1st power times b to the 4th. And finally, plus 1 times b to the 5th. That's called binomial expansion using Pascal's triangle. Now, it is going to get a little different here in a second, but I want you to do one more practice problem like this on your own. So go to page 537.
You got to collect these.
In just a second. I'm going to have you guys come up and show them to me. So go to page 500. Actually, it's 538, I think. Go to 538. There's a picture of Pascal's triangle at the top, yeah? Okay, that's the correct page then. I want you to do the problem 1, got it problem.
Should we write the rest of Pascal's triangle? No, you can think that way.
Do the problem 1, got it problem. On page 538. It's a plus b to the 8th power.
Just as much as you does.
Let's see. Let's have. Who's gonna come up? Who's gonna come up? Who's it gonna be? We have to have somebody come up. We can read the handwriting.
Yes.
Somebody that doesn't write in Chinese, like Dallin.
I will accept this.
Any volunteers, or am I going to choose? Who wants to write the expansion? You just have to write the final answer. Oh, come on! You got it? Thank you, Kate. There you go.
People better ask if you're looking at it.
It doesn't make me uncomfortable.
Because I've had you for a long time. When your teachers, when a student stares at them, you know, I didn't get called on like once last year in that because I stared at you.
What are you even talking about?
Except for when Jordan pointed me at that.
I think she's on a roll.
Put a 0.
What are you talking about, 0?
It's 1a plus 0 to the 0. Oh.
It's a 0 on top of a 0. It's a snowman. It's an 8. Then let me get you some room here. Hold on.
Little genome, actually.
There we go. I know. So if anybody ran out of ink during this one problem, you can have the school buy a new pen.
Really?
No. Oh, need more room. Hold on. I might even run out of room here.
Yeah, if I wrote that, we would have ran out of room.
Yeah. Fantastic. Thank you. Look at that.
Oh, I took up 1 here.
That's longer than the freaking alphabet right there.
Probably.
So it's a to the 8th plus 8, a to the 7th b. And you can read it here. The numbers are 28, 56, 70, 56, 28, 8, and 1.
It's longer than the alphabet.
It is. It's a big term there. This is all, this is all practice for the types of problems you're going to see on the test. You're not going to see these types of problems on your test. Okay? You're going to see a problem like this. Example. Expand. Write this down. Rather than using A's and B's,
You want us to expand this?
you're going to see something like this. X plus 4 to the 4th power.
Are you serious?
I'm deadly serious.
Have you seen the video of Chuck Norris reading Chuck Norris?
No?
Hilarious.
I'm pausing this. Here we go. X plus 4 to the 4th power. Check it out. It's not any more difficult than what we just did. It's certainly shorter. That's to the 8th power. This one's to the 4th power. It is different though. You got to pay attention here. Yeah.
Are you going to give us the Pascal's triangle?
No, you're going to have to make it. Here's the thing. What's the thing? Well, you said you had a thing.
It's a lot.
It's not that bad. What's the first one? What's the top?
1.
And then?
1, 1.
No, you just add the 2 numbers above it. And then it starts with a 1. What's 1 plus 3? And then 6. Come on, that took me like 12 seconds.
Okay, now let's get to the 10th power.
We're not going to have to do a 10th power on the test. You won't have to go much higher than 5 or 6. All right, so anyway, look at the 4th row of Pascal's triangle. Okay,
Now it's plus 1.
the first row, or the first number in row 4 is a 1, obviously. But instead of an A here, there's an X. But it still follows the same pattern, so it's going to be 1 times X to the 4th. Now we move over. What's the next number in row 4? One goes row 0, and then 1, 2, 3, 4, so it's a 4. So it goes plus 4. And then what should happen to the power of X? Goes down by 1, so it's X to the 3rd. But rather than having a B here, we have a 4. But it acts the same thing. It acts the same way. So we're going to multiply this by 4 to what power? All right? Then we move on to the next term. The next number in that row of Pascal's triangle is a 6. And then it's going to be x squared times 4 squared. The next number in that row of Pascal's triangle is a 4 again. It's going to be x to the 1st power times 4 to the 3rd power plus, we have a 1, 4, 6, 4, what are we missing? A 1 there, and then a 4 to the 4th power. So that's how you set up the problem, but this is certainly not your final answer. You wouldn't get full credit for just leaving it like this. You've got to simplify some of these terms. Okay? 1 times x to the 4th, that's just x to the 4th. Okay? The next term over, though, you've got a 4x cubed times another 4. So what's 4 times 4? So you'd have to change this into 16x to the third. You follow? All of these numbers in this term are multiplying. 4 times this 4 would make that into 16. So it's 16x to the third. All right? If you take a look at the next term here, you've got a 6, but you've also got a 4 squared. 4 squared is 16. 16 multiplied by 6 is 96. So that term becomes 96.
Sorry for the interruption. May I get Sharon Hare to the attendance office for checkout, please?
Yeah. Alright, that would be awesome. Almost. She was teasing me. Jared, here. Oh, damn. So anyway, it's 4 squared times 6. That's 96. So you've got 96x squared. On this term here, you've got a 4 times 4 cubed. That's 256. So that term becomes 256x. And then finally, you've got 4 to the 4th power, which is 256. So this would be your final answer right here. X to the 4th plus 16x cubed plus 96x squared plus 256x plus 256.
Yeah, I can't help but notice that
You what now?
Oh, God.
So it's the same process. It's a little bit different because you have more numbers and less variables, but you've really got to be careful with minuses. So this one's out of the book, but we'll do this together. This is the practice number 1 problem on page 538. What's that? This is practice number 1 on page 538, but we'll do it together.
There is a to the 10.
Well, not in the book, but not on your
No,
test.
that is there.
You better be careful. I'm going to put a 20th power on the test.
Just on balance.
Just on balance. And I'll give you 10 of those problems. Yeah. So row 3 of Pascal's triangle has a 1, 3, 3, 1. So we know those are going to be the numbers, or the coefficients in front of each term. So it's going to start with a 1 times x. What power? Power of 3 plus, what's the next number in that row of Pascal's triangle? 3 times x squared. Here's where you really got to be careful. The powers of x have to decrease by 1 every time. Or why am I adding here? That's what we've done with every term adds. But what should the next part of this term be? We have 3, because that's the coefficient from Pascal's triangle. We have x squared, but the b term here is -5, and that needs to be raised to the first power. Okay. What's the next number in that row of the triangle? Okay, so we've got a 3. X to what power? But now -5 is raised to the second power. Okay. We have a 1, we have a 3, we have a 3. Last number in that row is a 1. What happens here? 1 times -5 to the third power. Okay, watch carefully. What's -5 to the first power? -5 times 3 is -15. So you should have an x to the third and then minus 15x squared. Now this term right here, -5 to the second power. That's going to be +25. Now here's the thing. I know you guys know that, but sometimes you rely too much on your calculator. Watch what happens when I type this in. Negative 5 squared. It's not negative 25. I typed it in wrong. This is not a problem with the calculator. This is a problem with me. Okay? You've got to type negative numbers in parentheses before you square them, or before you raise them to any power, really. Negative 5 squared is positive 25. That's a big mistake students love to make, so don't make it. So at any rate, we've got 25 times 3, which is 75. So this turns into 75x. And then negative 5 to the third power is minus 125. So your final answer would look like this. X to the third minus 15x squared plus 75x minus 125. Okay? It's the exact same thing that we did with A's and B's. We're just doing it now with X's and numbers. It's the same thing. It's not different at all. Okay? So try this one on your own. Whoa, quit looking at the answers. Do x minus 3 raised to the 4th power. Try it. It may seem easy enough when I'm up here doing it for you, but if you actually have to sit down and do it on your own, it may be a different story. So you've got to try this. X minus 3 to the 4th power. That means it's going to use the 4th row, Pascal's triangle. That row includes a 1, 4, 6, 4, 1. So I've got 1 times x to the 4th. Then I've got a 4, x to the 3rd, negative 3 to the 1st power. Then I've got a 6x squared, negative 3 squared. Then a 4x to the 1st, negative 3 to the 3rd. And then a 1 times negative 3 to the 4th power. And you simplify it. This should be your final answer. X to the 4th minus 12x to the 3rd. Is it a plus or minus? Why is it a plus? Negative 3 squared becomes positive 9. Yeah. 9 times 6 is 54x squared. Oh, mama. Let's see. 27, negative 27 times 4. I don't know. It's something. Minus 108. 108x plus 81. So x to the 4th minus 12x to the 3rd plus 54x squared minus 108x plus 81. What's this called? This type of mathematics? What's the title of the lesson? Binomial expansion. What is a binomial? 2 terms. This is a binomial, yes? We took a binomial, we rose it to the 4th power, we expanded the binomial. This is called binomial expansion. What do you use in binomial expansion? Pascal's triangle. It's Pascal's triangle. If we didn't have Pascal's triangle, then we would have to use the Foy method, which would really stink. There's one more type of question here. It's actually easier. Write this down. But then just write it down, that's it. X plus 7 to the 5th power. Just write it down. Rather than expanding the entire thing, on your test, you would have to answer a question like this. What is the 4th term? Just the 4th term. Now you can find that without having to expand the entire thing. Okay? if you're raising it to the 5th power, look in your book, the 5th row of Pascal's triangle. What's the 4th number in row 5? So we know it's going to involve a 10, right? Now, we also know it's going to involve x to some power and 7 to some power. We just need to figure out what those powers are going to be. So think about this. The first term, x is going to be raised to the 5th power, correct? What about the second term? 4th power. The third term would be the 3rd power. The 4th term would be the 2nd power. So we know x is going to be raised to the 2nd power. And automatically we should now know the power of 7, because if you add these two powers together, it should equal 5. So what's the power of 7? 3. Exactly. So then you take 7, raise it to the 3rd power. That's 343. Then you times it by 10. It's 3,430 x squared. That would be the 4th term. So you have a couple questions like this on your test where you just have to tell me one specific term, not the entire expansion. Do you understand the difference? Okay, try this one. This is our last problem, then we're done. X minus 4 to the power of 6. What's the 5th term? Go! This was the 4th term.
Oh.
So in the 6th row of Pascal's triangle, the 5th number in, what was it? 15, yeah. So you know it's going to involve 15 and then a power of x and a power of negative 4. So initially you should have written this 15. And then by the time you get to the 5th term, x has a power of 2 in that case. And if x has a power of 2, that means negative 4 has a power of 4. Negative 4 to the 4th power is 256. If you multiply that by 15, you get 3,840 x squared. Well, hold on. Don't put your books away. Well, I guess you can put your books away, but not your notes. Rather than an online assignment, I've got 6 problems for you guys to do at home. So copy them down before the bell rings. These are the 6 problems. There weren't a lot of good online problems, so I'll collect the worksheet next time.